Hey, good morning. Assalamualaikum everyone. Can you hear me clearly? Can you see my slide? Can you see my slide? Can you hear me? Can you hear me? Am I not audible?
Yes, please.
Okay. Please respond when I ask question because I'm not sure whether you can hear me or not. Okay, thank you always for responding. Okay, now we proceed to our class, which is the last topic, the solving ODE system. Now, ODE stands for ordinary differential equation. Okay. Ordinary differential equation. Okay, so we will use this kind of ODE system which to predict the new point. Okay, so for we have came across so many times last in the previous topic where we know that I make it bigger. Okay, where we know that the dy dx is equivalent to the slope. Okay, this one is slope. When you have a function, okay, when you have a function, the dy dx is the slope of the function. Okay, so this is delta x, then this will be your dy. Okay, so this is slope. Then the slope is equivalent to dy dx lah. So this one, it means function of x and y, the function. So the dy dx itself, it has their own function. Okay, so for example, here, this example, dy dx, this equation, don't focus on this one. Okay, what I want to mention is the ODE. Okay, we focus on Euler's method. We have two methods, Euler's and Hans method. Okay, the first one is Euler's method, where it used to predict the new point. Okay, so we know that dy dx is the slope. So the slope comes from this equation, the dy dx lah, the delta y over delta x. Okay, the difference. Then from this equation, we can use the relation to extrapolate linearly from y1 to yi plus 1. yi to yi plus 1 means from the original point, okay, let's say here is your yi, so in order to predict your new point, okay, we can use this Euler's method, Euler's equation. From this, rearrange, then you will get this. Okay, so here from this, I show the yi plus 1 minus y over this equivalent to this. Okay, which is this one is the dy dx. Okay, so we bring all to the right side except the yi plus 1. Okay, then that's how you get the equation. This part is the h. Okay, plus multiply by the h, then plus y. Y here is the yi. Okay, so that's how we get this equation is this one. This equation is used to predict the new point in Euler's method. Okay, for example, here we have the slope. Okay, we have the slope. Then at this starting point, you want to predict the new point. So you use the Euler's method, Euler's equation, to find your new point, yi plus 1, which for the true value, you can get somewhere else on the point. Okay, the true value, you will need to use the actual equation, actual y equation, or fx. Okay, later we do the exercise, then you understand more. Okay, in summary, Euler's method is the method to find the predicted point. Okay, predicted point. So this is your predicted point. Okay, here from this one, okay, here, this, you see, from this point, to predict the next point using Euler's method, okay, using this equation, you will get this predicted point. Okay, remember the slope, it is a straight line touching our starting point, the slope. Okay, similar to this. The straight line touching the initial point. Then you get your predicted point. This is the predicted value, predicted point. And this which is the true value from the actual equation. Now you see the difference? There is the error over here. Okay, this is we call as the error. Okay. Now we do this example. Given example, y prime. This y prime means the dy dx. Okay, the slope equation. Giving this example, okay, this equation, then y0 equals to 1, meaning that at x0, y equals to 1. So this is your starting point. Okay, that is your starting point. Okay, then it mentioned Euler's method on the interval 0 to 1 with h 1 over 2, which is 0.5. Okay, interval here means the range of your point. Interval means in this case, x-axis is the t. Okay, t, what? T. Y-axis is y. Okay, now your t, the interval here means the t value is from 0 to 1. Okay, so this is your interval with step size of 0.5, half. So step size 0.5 means that this is your another point. Okay, so this is your another point, step size. So that's why you see there are 3 points over here. Okay, now we go step by step on how to solve this. Exact solution is the equation to find the true value. Now, exact solution here, you see, it is the initial y function, not the differentiation of it. The initial y function, okay, the original y function. Okay, so we go step by step. First step, you need to identify what is your dy dx, your starting point, then your step size, and your interval. Okay, because we need those data. Now, we know that from Euler's equation, yi plus 1 equals to yi plus fxy over here multiplied by the h. Remember, this one is dy dx. Okay, so this is dy dx, not the original function. Okay, now you need to create a table so that you can see it clearly. Okay, I would suggest you to do the table where this is your point. Okay, from 0 to 1, the interval 0 to 1, but your step size is 0 0.5. So 0, 0 0.5. Okay, then this is your y Euler, ye. This is y true, the true value. If the question asks you to find the error, then you add one more column for the ET, true value. Okay, now here I would use the numerator over here. Okay, I starting from 0, 1, and 2. Okay, now we start with Euler's value. Okay, ye. From this example, it already gives you the starting point. So at t0, okay, this one t, don't make yourself confused. T0, y equals to 1. That is the starting point, similar for the true value. Okay, so for the next one, y1. Okay, y1, we want to predict the next value, the y1. So y1 equals to y0 plus the dy dx value, then your h. Your h is 0 0.5. Okay, so now y0 is the previous value, which is 1, plus, okay, this one, you subs the value to here. Okay, your y, the previous y, okay, 1 plus 2, 3, the previous value. We want to find the current value, so we use the previous value. Okay, minus 1. Multiply 0 0.5. What you get? Sorry? Cannot hear you. 1, yes, correct. So y1 equals to 1. Okay, y1 equals to 1. So here we put 1. Okay, so that is why you see over here at t0, y equals to 1. T 0.5, okay, t 0.5, which is your y1, still equals to 1. This is the predicted value, predicted using Euler's method. Okay, next to find y2. Okay, to find y2, where should I put? Okay, now y2, your y1 plus the fx, then the h. Okay, so y1 is 1, this one, y1, 1. So we use this equation, then plus 2 multiplied by the t1, which is 0 0.5. Okay, then minus 1. multiply by 0.5. Now what you get for your y2?
1.5.
Correct. Yes, 1.5. Okay, so here you put in 1.5. That's why you see over here the predicted value is 1.5. Okay, try to calculate for true value yt when t is 0.5. True value using this equation. What you get for your second true value over here?
7.
1.297. Yes. Next,
0.4 meters.
2.437. Okay, again I repeat this one using this equation, this one using the Euler's equation. Okay, where Euler's equation, you need to find the dy dx of the actual equation. Okay, any question? Okay, if you have question, please voice out. Do not type because when I go to the slide, I didn't see the chat box already. Okay, if you are clear, then we move to the next example now. This one still the same interval, but then different h value. So the step size will get smaller. Okay, the step size getting smaller. So we can see how is the trend of the y Euler. Using the same equation, now generate your table. Zero, okay, interval is from 0 to 1. Step size 1 over 4 means 0.25. Okay, so your points according to the steps until 1. That is your range. Okay, the interval means from the lower range to higher range. Okay, now this is your denominator. Okay, next is to find the y Eulers. We just find the y Euler. Y true you can calculate on your own later on. Okay, using the same equation for the dy dx as previous. So the equation is identify the equation, which is the previous one is y plus 2t minus 1, which is this is the dy dx. Okay, your starting point is at 0, y equals to 1. Now, to find the Euler's, the y Euler, we know that y Euler is from this equation. Okay, so for y1, y0, starting point, y equals to 1. Next, we need to find for y1. y1, y0 is, 1. Equals to 1 plus 2 previous value of t. Sorry. 1 2 0 minus 1. Okay, so y1 you still get equals to 1. Okay, y2 using the previous value y1, which is 1 plus 1 plus 2, 0.25 now. Okay, 0.25 minus 1 multiplied by h, 0.25. What you get for y2?
1.125.
Right, 1.125. So try to proceed the rest. For y3 and y4. What you get for y3?
1.23.
1,
1.5.
1.37.
1.37.
The rest get the same. y4, how about y4?
1.75.
1.75. Otherwise, you get the same. Okay. Okay, so I hope you know how to calculate the YE, the Y Eulers. You can proceed to calculate your yt. It should be the same as the previous one. Not the same, like similar, because now we are reducing the step size. Okay. Okay. Next, this one, the h value is getting smaller. Okay, you can see the trend. Okay, wait before that. Okay, here for 1/4 interval, you have 4 points. Okay, 5 points. 1, 2, 3, 4, and 5. Okay, so but when h equals to 0.5, you only have 3 points. Okay, you see the error for each of these. H equals to 0.5 and h equals to 0.25. The error value is reducing. Okay, this is the error area. It is reducing. Then when the h getting smaller, step size getting smaller, the error is reduced. Okay, so Euler's is predicting the next point. The smaller the h, the smaller the error. Similar to the integration before this. The more segment, the smaller h, you'll get more accurate values. Okay, so this one is when h equals to 1/8. So you will have more data points. Okay, then the error also reduce. Okay, this it compiles all the h trends, the data points with different h value. Okay, this is the 1/8. Okay, 1/2, 1/4, 1/8. This is 1/16. Okay, you can see the trend. The smaller the h, the more points you have, then the lesser error. Okay, any question? Okay, no question, I proceed. From this example, okay, using this example, solve the following initial value problem by using Euler's method with step size of h 0.1 and step size h 0.02, 0.05 on the interval t 0 to 0.5. Okay, now this table, as of now, you just ignore the y correction. We focus on the y prediction. Okay, y correction here, it involves the Hans method, different, the next method later on. Now we focus on the Euler's method. First thing first, identify what is the equation involved. Okay, this is the equation involved, the dy dt or dy dx. What is your starting point? Okay, starting point. This is your starting point. Then the h value. Then look at what is your interval, your data range. What is your data range should be? Okay, we do it step by step. First, the equation. Okay, dy dt. Dy dt. Okay, this is the equation. Now we must get the correct equation. It should be dy dt equals to the function. So from this equation, you need to rearrange so that you get dy dt equals to the function. Means this one bring to this side. Okay, if not, you cannot solve later on. Okay, that is your equation that you will use for the Euler's method. Okay, then step 2, your starting point. Okay, starting from here is given as this. Y t equals to 0 equals to 1, meaning that at t0, y equals to 1. Okay, then your step size we just take for 0.1 first. Step size, that is your h. Okay, next one, what is your range? The interval is mentioned as 0.5 interval. Okay, notice on the bracket, this is the interval, not the coordinate. This one means interval, meaning that from x0, from x, sorry, this one is t, t, not x. From t equals to 0 until t equals to 0.5. Until t equals to 0.5 with this step size. Okay, so we know that the Euler's equation that we need to use. Make sure it is the correct equation. Okay, then come out with your table. T from 0 to 0.5 with step size of 0.1. So step size, each 0.1. Okay, so your I starting from 0 okay. Then find your Y Euler. First one, when t equals to 0, y equals to 1 over here. So we just put, that is your starting point. Okay, now let's calculate for y1. Okay, let's calculate for y1. So y0, which is 1, plus the dy dx, dy dt value, which is this equation. Okay, so 2 minus exponent negative 4 t0, t previous. So t previous is 0, then minus 2y. Y here is the previous value. So previous value is 1. Okay, then multiply with the h. Your h is 0.1. Try to calculate what you get.
1.
Huh? 1.
No, no, no. 0.9.
0.9. Yes, correct. 0.9. Okay, 0.9. So your y1 is 0.19. Then proceed with y2 with the same approach using the previous value. So previous value is 0.9 2 minus exponent for previous t. Previous t is 0.1. 2 previous value is 0.1. Multiply the h.
1.01.
1.01.
Let me check again.
No, it's not the answer.
0.5.
No, 0.8529.
Yes.
Right, 0.8529. Okay, so for y2, 0.8529.
Miss, the Miss right wrong.
Which one?
The
Oh,
minus 2 times 0.9.
yes, correct. Sorry. See, I also get it wrong. You must replace the correct value. Yes, correct. This should be y previous value 0.9. So the previous value of y. So then you get the correct value, right?
Yes. 0.8.
0.3. How about the y3? What you get? You can set the equation in the calculator with the unknown a and b, two unknowns over here, p and y. Then you just replace the value. Okay, how about y3? What you get?
0.8374.
Correct. 0.8374. Y4? y4 you should be getting 0.8398, 0.8516. Okay, so this is how you answer the question. Show your y value in a table. Much better. Okay. Okay, this example extracted from textbook. It asks you to use Euler's method to numerically integrate. Now, this is the given equation. Okay, the dy dx from x0 to x4. This is your range. Okay, from the table here you can see from x0 to 4 with step size of 0.5. Okay, so each of these is the h step size. With initial condition at x0, y equals to 1. So at x0, y equals to 1. Y true 1, y Euler is also 1, the same starting point. Okay, recall that the exact solution is given by this equation. This is to find the y true. Okay, so from here you see it calculated for each step size, each x value, the y Euler. Okay, we focus on the y Euler. So you see the range of the values, then the error. Okay, the error. From here, the error is, you can see there are variation of error. Okay, it is convergent and divergent. Then it represented to you in graph. Okay, this is the true solution, and this is the y Euler's, the Euler's method. Okay, this is the error, the area of the error. Okay, take note on this. You see, increasing, see increasing. Cos from the predicted value to the true value. You can see the big difference. Then it decreases back. Okay. Then it increases back. That's the reason you get this trend of error. It depends to the function. Okay. Now we try this. This is final exam September 2021. Now it asks you to consider the following differential equation, which given as this, where the point x naught y naught is a point on the curve of y versus x. Compute the value of y at x equals to xi by using Euler's method with the step size of this. Okay, it's given. Interval is from y with x1 until 2.25. Okay, with the starting value of x1 and y 1.5. Okay, this one is your starting point. Okay, then you get this set of x value from the h. H is 0.25. Okay, in this table, it shows you the data for yi, f. F here is the value of the dy dx. So this solution, it shows you the step by step each of the values. Remember the Euler is yi plus 1, then yi plus fx and h. So yi, that column, this one, this column. This one is the predicted from yi. So you see the same value, this and this. Okay, for me, okay, this one is from other lecture solution. But for me, it is sufficient for you to show the x and the yi plus 1, the y Euler. Straight away show the y Euler. Okay, you can do this kind of table as well, no issue, as long as you get the correct value of y Euler. Okay, this one we just discussed. I just explain on Hans method. Okay, Hans method will not be asked in final exam, only Euler's. Okay, but Hans method is the improvement of Euler's method. Okay, I explain Hans first before we do the next final exam question. Okay, in Euler's method, the slope at the beginning of an interval of the dy dx is used to extrapolate linearly to the yi plus 1. Okay, in Hans method, the y is not yet the answer. Okay, this is from Euler's. Okay, so here it means your final value of Euler's is not yet the final answer, but an intermediate prediction. Okay, in this case, we can use the corresponding value to estimate the slope at the end of interval. So this is Hans method. Okay, what does it mean by this is, in Euler's, let's say you have so okay, then you want to predict, this is the initial point, you predict using Euler's, means the slope of this point. Okay, so this is your predicted using Euler's. Okay, but for Hans, Euler's is just the intermediate, not yet the final answer. Okay, for Hans, it will half the error over here to get the value of the next point. Okay, wait, I show you before we move to this. Here. Two slope values can be combined together to obtain an average slope for the interval. Okay, then this average slope is then used to extrapolate linearly from yi to yi plus 1 by using Euler's method. Okay, so Hans method, they use two combined slopes to take the average. That's why you see over here, divide by 2. The enhanced method is a predictor-corrector approach. The method can be expressed as this. Okay, this is the Euler's equation. This is the Hans equation. Okay, here. Predictor, we use the Euler's. Okay, you can see the predicted point over here. Yeah, okay, predicted point. The Euler predicted point using Euler. Okay, but for Hans, it takes the average of the slopes. Okay, so this one, the error over here, divide by 2. Then it will get closer point to the true value. So using Hans method, you will get a closer value. So value that is closer to the true value. In fact, it can get up to exactly on the true value. Okay, Hans is the corrector. Euler's is predictor. Hans is the corrector. Okay, Hans. This is the representation of the Hans and Euler's. Okay, this is the true solution. So Euler, you can see there is still big errors. So when you use Hans method, the corrector, you get smaller error. Okay. We proceed to this final exam question. Now, this is final exam May 2023. This question, one question, I combined into two topics using one main equation. Okay, so given a non-linear function of this, non-linear. For question 1, it asks you to predict the root of the function by using bisection method. Okay, this one is the earlier topic, the bisection, with the range of this. Okay, this one later you can try. Now we want to focus for B. B, it asks you to compute the value of y from x equals to 0 to x2 with a step size of 0.5 by using Euler's method. Okay, Euler's method, where the initial point is x0, y1. Okay, your answer should include the true error. You see there, the marks provided is 12 marks. Okay, first step in Euler's method, the dy dx equation. In this question, it doesn't give you the dy dx equation. So you must find out on your own. This step must be correct first. If you get the wrong dy dx equation, then the rest of your answer will be wrong. Okay, so from the main equation over here, what is your dy dx equation? What is it?
Negative 2x power 3
Mm-hmm.
plus
X
12
squared, X squared.
Mm-hmm.
minus 20x
Yeah,
plus 8.5.
correct. Yes. Okay, this one you must get it correct first. Then step 2 is to identify what is your h and your starting point. H is 0.5, starting point x0, y equals to 1. Then what is your interval? Interval x2, sorry, x0 to x2, from x0 until 2. That is your interval. Then what is the equation involved? Euler's method. So Euler's, using the Euler's equation. Okay, then only you can generate your table. X. Identify your x first, starting from 0 until 2 with the step size of 0.5. So 0, 0.5, 1, 1.5, 2. That is your point. Okay, then find your y Euler. Okay, before that, our starting point is given, so start with 1. Y equals to 1. Y0 equals to 1. So to find y1, subs the inputs into the Euler's equation. Okay, and this one is 1 plus, here you use the dy dx equation. Okay, negative 2 x 0 0 easy lah to calculate, all 0, then 20 0 plus 8.5. Okay, then multiply with the h, which is 0.5. What do you get for your first y1?
5.25.
5.2.
5.25, yes, 5.25. Okay, try to calculate for the rest. Remember, you should find the true error, so you must have yt as well. This is y Euler, so y true. Then your error, true error. Yt, the first y start with 1 as well. Okay, y Euler, y2, what do you get for y Euler?
5.875.
Correct, 5.875. Y3, 5 point,
125.
correct. So the last one is 4.5.
Yeah.
How about the true value? Y1.
3.219.
Yes, correct. This one should be 2.192. Okay, I speed up a bit. Okay, so here the error first none. One should be 95.8. 131.0, then 1.125. 74. 24.7. Okay, so each values there will get marks. Make sure you get it the correct value. Okay, any question? Okay, so we are done with the last topic, ODE. That's all. Euler's. Okay, the rest of the question of final exam you can see from CN. Okay, try to do it. Practice. Okay, so any question before I move for the final exam briefing? Okay, no question. I stop sharing the slide. And discuss on the course outline. Okay, final exam question as usual. 5 questions. Answer all. Please answer. Try to attempt all questions. Okay. Do not leave out any questions. The final exam question will be based on this CLO. According to the C course outline over here, final exam covers CLO1 to CLO4. Okay, meaning that from this to this. CLO1, the earlier topic, the chapter 1, which the compute the root of non-linear. Okay, this one, the close method, the bracket method, open method, okay, the bisection, Newton-Raphson, secant method, fixed point iteration, all those things. Okay, by using iterative method. Okay, as you can see here, there is no not mentioned graphical. Okay, it mentioned iterative only. So graphical will not be in final exam. Okay, CLO2, which is solve the linear algebraic equation using direct and iterative. This one linear. The linear is the Jacobi, the Gauss-Seidel, matrix, okay, LU, the matrix, the Gauss elimination, LU, okay. Then ZO3 is the polynomial equation by using interpolation. Okay, this one interpolation, the Newton divided difference and Lagrange. Those two. ZO4, the integral and differential equation. Okay, integral here we have trapezoid, Simpsons, both Simpsons, Romberg, unequal segments, yeah, Then differential we have the forward, backward, centered. Euler's is under differential equation. Okay, the ODE. Okay, so those are the topics covers in the final exam. Mostly all topics lah, but you can practice using the previous final exam question to see how is the question designed and how to answer it. Okay, try to practice using the calculator so that your calculation will be faster during the final exam. Okay, make sure you know how to set the equation in the calculator, the matrix. Okay, what are the steps to be taken in order for you to solve the matrix? Okay, any question?
Yes.
Yes. No, no question.
No.
Okay, wait, I want to share with you the okay, for the finite differential equation, the forward, backward, and centered, make sure you are familiar with the terms. Which one is forward, backward, and centered? You will be given the odd equation without labeling, so you should know which equation refers to which. Okay, I think that's all for your final exam. All the best. Try to answer correctly. Hope you can answer everything. Okay, all the best to you. Good luck. For those who haven't scanned, okay, I share again the attendance. Once you scan, you can leave the class. Okay, that's all. Thank you. I will upload all the videos in my YouTube channel.
Thank you, Miss.